Good day everyone, I am Teacher Cristel and welcome to my YouTube channel. If you want to know more about tutorials, you can always visit my channel. So today, we will talk about introduction of polar functions or polar coordinates rather. So first, let us know about what is the meaning of polar coordinates. So when we say polar coordinates, it uses distances and directions to specify the location of a point in the plane. To set up this system, we choose a fixed point 0 in the plane called origin and draw from 0 to ray half line called the polar axis. Then each point P can be assigned polar coordinates P contains r and theta, wherein our r here is the radius. So for you to understand it better, let's have an illustration. So let's have here the illustration. Then we need to use different colors for you to understand it. So let's have point here. Okay. Now, as you can see, the point here is our origin. And when we say origin, it is a fixed point. Ayan. And it is denoted by 0. And this point is our P contains R and theta. It's like that. And now, how we will find the R? So, it is said here that R is the distance from 0 to P, or how much you go out from the origin. Since our origin here is here, so we can find the R from the distance from 0 to P. And like that. So this is our R. And to find the theta, it is the angle between the polar axis and the segment. So when we say polar axis, when we extend a ray from origin to, it's like that, to the right side, this will be called the polar axis. So let's consider it as a polar axis. Then, so our theta will be here. And that's it. This is our theta. Now, it is clear to you what is the meaning of polar coordinates. As I said rather before, it all about distances and directions. Now let's have here r is equal to a sine theta. As you can see here, our a is positive. So always remember that if our a is positive, the circle will be, let's consider it an straight line. Our circle rather will be on the right side. So here it is. Then this is the half of A, or the diameter, and this is the distance or the diameter of A. So the circle is on the right if our A is positive. Always remember that. So how about if our A is negative? Yeah. So, if our A is negative, the circle will be on the left side. Let's consider it is a perfect circle. So, and then the point, this is our center. Then this will be the half of A. The half of A. Let's consider the A. Then this is the diameter of A. So that is when our A is positive, the circle could be on the right side, and if it is negative, it could be on the left side. Now, let's have an examples. We have here r is equal to 4 sine theta. So, we can graph it through this. Since our A is positive, which is 4, our graph will be so first all we're gonna to do is traveled 4 units to the right since it's positive. So 1, 2, 3, 4. And then 2 unit, let's say our A is 4, then half of A is 2. So we can travel 2 units up and 2 units down. And then the circle, let's use different color. Then the circle starts at the origin. So this is our origin. And then the 4 axis. And then what is the half of A? It is 2. So 2. Here it is. Then also here. After that, you can connect the dots. Okay, and that is our and that's how to plug the function or the given r is equal to 4 sine theta. As you can see, our A is positive, which is 4. So if you can see in our previous discussion, if A is positive, the circle is on the right side, which is correct. And if it is negative, it's on the other side. So that's how you can graph r is equal to 4 cosine theta. I hope you will you get it. So let's have another one. Let's have r is equal to negative 6 cosine theta. Here, the circle is on the, let's have a graph first. Our circle is on the left side since our A is negative, which is negative 6. So let's have first the A and the half of A. So our A here is negative 6. So since it's negative, so we traveled here 1, 2, 3, 4, 5, and 6. Then half of A is negative 3. So we can travel up 3 units and also down 3 units. Don't worry, by the way, don't worry about negative too much. It is only to know if the circle is on the left or right. Okay, so let's use another color. The center is on negative. And then our A is negative 6. So the dot will be here. And then our half of A is negative 3. So it is here. And negative 3 again down. So it is here. And then again, we can connect the dots. So it is like this. That's how you can plug a circle with the given function r is equal to negative 6 cosine theta. And then the half of a, as you can see, the half of a is simply the radius of the circle. Yan, radius niya. This is the half. And this is also the half. Okay, I hope you get it. And now, let's have here r is equal to r is equal to sine theta. In here, we have the sine, which is associated by y value. So the circle is on the y values. So let's have the presentation for you to better understand it. So here it is. We have here, consider it a straight line. So it is said that the circle is on the y values. So our circle will be here if our A is positive. And then this is the half of A. Half of A. And then this is our diameter or the distance of A. And the circle would be centered on x-axis and goes above y-axis. It is if our A is positive. So what if it is negative? So when A is negative, our graph will be like this. Let's change another color. And it's open in y direction, so it's gonna below on the y axis. And this is our diameter A. And then this is the half of A. I hope you can follow, guys. The half of A. Yan. So if our A is A sine theta is positive, so our circle is on the x-axis and goes above y-axis. And when A is negative, using sine theta is our circle is open on the y direction, so it's gonna below the x-axis. So now, let's have an example. Let's have here the r is equal to 4 sine theta. So to graph it, it could be like this. So let's use again. So our A is 4. Then half of A is 2. To graph it, so we have 4. So let's travel the 4 units up. 1, 2, 3, 4. And then 2 units, since our half of A is 2, 2 units to the right and 2 units to the left. Yan. And then our origin is here as always. And then our A is 4. So here is the point, and then the half of A is 2. So here it is, the point, and then here. After that, we can connect the that's. And this is gonna be the graph of r is equal to 4 sine theta. So pardon me about the lines. And now let's have r is equal to negative 16 sine theta. On the last example, our A on that is positive. So now our A is negative. So to graph it, so it is like this. Let's have a graph. And then our A is negative 16, right? And then half of A is negative 8. So let's travel 16. Oh, let's change again the color. 16. 1, 2, 3, 4, 5, 6, 7, and 8, and 16. Example, it is 16. Yeah, like that. And then our half of A is negative 8. Let's say it is here and traveled 8 to the left. Negative 8. So this is gonna be the graph. We need to point it out. So our A is negative 16. So it is here. And then have our origin. And then half of A is negative 8. So here it is, and there it is. It could be circle because we don't have much line. So when we connect oh my god, when we connect the dots, so it could be like this. So now this is the graph of r is equal to negative 16 sine theta. Now let's have an example. How to plot 3 and 3, 45 degree. So to plot this, let's have here, since our r is 3, and then the theta is 45 degree. Since our r is 3, so we can make a circle here 3.
Basahin mo muna.
1, 2, 3. So 3. And
Patatingin